So, what we're trying to do is solve the simultaneous equation. We have been through this before. So we've got our train problem, 3x plus y is 200. Now these are very simple ones. Okay, you've already solved it algebraically or even through common sense. Do you remember what the answer is again? So 1x has a difference of 71, wasn't it? Therefore the y, well that would make that 142, so y has to be 53. Okay, so we know our solutions. Now what I want to be able to do is solve them though using a graphical method, so using graphs. So I'll ask you to put them into your calculator, right? And what we're looking for again, where the two lines intersect, where they cross. Now, having just looked at one of your calculators where it wasn't coming up, now the problem is, because you put in, what was it, fx equals 3x plus y equals 195. Who did that?
I did. Oh, you have to make them into one. But how do you find out intersecting?
Right, hang on. So, don't forget, this is an interesting thing to discuss.
Mine's F1.
Yeah, right. F1, first function, second function, FC. Yeah. F of x equals that. Now, what's wrong with this to start with?
We didn't put a y.
Oh, there is a y?
No, I meant like in the x.
There's two equal signs. That's it. Exactly what I was going to say. There are two equal signs. Can't do that. So I think, as you said, Jen, we need to rearrange it. So, because the calculator starts us off with, all right, f1x equals. Now, function of x, f of x, fx, means do something to x. And what comes out? Y comes out. So f of x actually stands for y when we're graphing our function. So f of x and y are interchangeable depending on what we're trying to do. So if we're just purely working algebraically with the function, we don't want to draw the graph, we'll leave it as function of x is. If I want to plot it on a set of axes, then it becomes x and y, because the x coordinate and the y axis. And we have the x coordinate and the y coordinate. So you may see, if we were to do a set of axes, excuse me, so you would recognise this axis as the x-axis and this axis as the y-axis, but this axis could equally be called the f of x axis. Does that make sense?
I did it.
So a coordinate here might be x and y, expressed as x and y, but a different coordinate I could say is x and f of x. Now we're going to do much more on functions and things as the year progresses, so just to let you know that f of x and y are interchangeable. We can use either. So what that means is, what do I have here? I actually have two y's. So I need to rearrange this so that actually this is no longer there as well as that. I have only one of those. So I need to rearrange it so that I have y equals. So what would it be? Y equals?
Would it be 195 subtract?
Exactly.
Yeah.
So I've got 195 subtract 3x.
Well, let me redo the graph.
So if you put that in, and then the other one, the second function is going to be, so 266, actually no, so it's not that, is it? Sorry, it's not 3x plus y was 195, was it at all? It was 2x.
Oh, that makes sense.
And then this one,
Sorry.
okay. So then this would be 266 minus 3x.
It won't show up. Because you have to make it, the view out.
So what we're trying to do then is on our axes, we need to see. Now, we should know, actually, what do I need to include? I know where the intersection is because I've already solved them. I don't always know, but what do I need to set my window to? What does x need to at least go up to?
100? I mean...
Well, minimum it needs to go...
70, I didn't know. 71.
71.
72.
So it needs to go past 71, so I'd go up to 80 or something. What could we do? We could set my x minimum value to maybe 65 and my x maximum value to
How do you do that?
75. Okay. And I could set my y minimum value to what?
50.
50. My y maximum to 55.
How do you do that?
Okay, how do we do it? Now I can't show you on my screen unfortunately, but on your calculator, have you got your graphs in front of you? Alright, okay. You need to, right, just listen to us as well as do stuff. So on your graph, press your menu button, okay? You should then have a window setting, is it? Right, go up, click on the window zoom setting. Now at the top, you'll have a window setting. Click on that. Alright, that allows you to set the x minimum, x maximum, so it sets the window. Now, if all you've done is click zoom, fine. You can actually fit the function as well. There's also an option to do that. However, it doesn't always work. So if you're now not doing the whole x min, x max thing because you've already got what you wanted, next time you won't know. So make sure you can go into your calculator and change the window to what you want it to be. It's confusing because you've not got your calculator to do it because it's not charged. Watching other people do it does not cut it. You have to have your calculator and do this sort of stuff regularly for yourself. Right? Mrs. Day made a great point about you can't learn to drive sat next to someone driving. Because as soon as you get in control of that car yourself, you might know that you're supposed to turn the steering wheel and press the pedals, but actually doing it is another thing completely. Right? Quite a different standard of what happens, but you have to use your calculator and practice using it. Alright, so we found the intersection. So what did it look like, by the way? Just a line. In what direction? So we've got two lines that basically do this, yeah?
Yes.
Yeah? And we've got a crossing point there, and we know that the x value is 71 and the y value is 53. Okay? So that's how we can do it graphically. Now what we have to be able to do though is do this without our calculator as well. Alright? So it's one way of doing it is with your calculator. You can see what it's supposed to look like, but we need to be able to plot the graphs ourselves without needing to use a calculator. Alright? So, should we have a look at how we would do this?
Can you make a new graph on a scratch pad, or you have to make a
I didn't know what's Y and what's X.
What do you mean?
I'm like between the blue and the red.
I don't know what you mean.
So you have 73 and 53. How do you know which one's X and which one's Y?
Because that's how I set it up, didn't I? So my problem that I had, the 2x was red. I had 1y. So I decided that the red was x myself.
No, I meant like on the calculator, say you have a question.
Well, x is along the x-axis. How did you all find the intersection? Do you all know how to find the intersection?
Yeah. go to menu, thing, analyze graph.
Yeah.
And go to intersection.
And you find it.
graph.
So the value that comes up as x is the one that you've identified as x.
Yeah, it does. There's always the first point
And X is the horizontal axis.
Yeah.
and the whole difference is X. It says X right there. And then you want so it would be X and then you want.
Okay, what we're going to do, before we can really go into solving and plotting and drawing the linear functions to find out where they cross, I want you to know everything about the linear functions themselves. So we're going to recap that sort of stuff. All right. So, what do we know about linear functions? So, for instance, if I were to ask you what the equation, okay, of the line with, what should we say, gradient 2 and passing through 1, 4. So if I gave you that information and said, what's the equation of that line? So we can put our calculators down now, we don't need them. Right. So we just have to be able to do this ourselves. Who would know what the equation was? So what's the equation of the line with gradient 2 passing through 1, 4?
Infinite.
I want an equation. There is only one line that has a gradient of 2 and passes through 0.14. Right? There's an infinite number of lines with a gradient of 2, and there are an infinite number of lines that go through 1, 4. But there's only one line that goes through 1, 4 with a gradient of 2. Okay? So no one's sure how to do that. Right, okay, that's fine. That's what we need to know. Do you know what we mean by a gradient of 2?
Yes, you go up and across and up.
Does everyone know what we mean by gradient of 2? Yeah? Okay. So, we've got rise over run equals 2. Well, what does that mean? So is there anyone that doesn't know what about that? Rise over run equaling 2. Everyone knows what that means. So I could pick any one of you and you could explain it to me in detail.
Well, I just
Yeah?
know rise over run.
But what does that mean?
I know what it means.
It's like
Yeah?
the line, rise. You make a triangle, right?
Okay.
Isn't like
So
how far it goes
A
up?
rise is
Like
Okay.
going up the y-axis, so you rise, and then a run is running across the x-axis, and from that point and this point, the answer or the gradient is what meets them.
Okay, so what you seem to be saying is if I go across, okay, so I have a starting point, and if I go across a certain value, right, if I then go up to another point that lies on the line that I'm talking about, okay, I will run so far, I will then, depending on how steep the line is, I will have to rise a set amount, yeah? So, if I have a gradient of 2, that means if my run is, well, let's say I went across 4, how far would I need to go to get back up to the line? Yeah? Right, so that's what rise on. So you're happy with that then? Yeah? Rise over run. Where does that fit into things then with the equation of the line?
Is it just any random line that we're choosing?
No, I want this specific line, gradient of
How do you
2.
know which point?
So basically then, I know, if you like, use this information. I've got a line. It goes through point 1 4. So one of the coordinates is at 1,
I know
4.
how to do this.
So, I know it's got a gradient of 2, which means if this coordinate is 1, 4, let's say I run 4, what will this coordinate be?
Two,
It'd be
6,
2 and 8.
2, 8.
I've run 4.
Oh, it'd
So
be
if that's
5.
1, it would be
4.
5 and 12. Okay, so the coordinate here would be 5, 12. Okay, make sense?
Why is it 12?
Because I started at 1, 4, so my y coordinate is 4, my x coordinate is 1. If I happen to run 4 across, my run is 4, I get to 5 on the x-axis. That means I have to go up 8 to get to another point, which has to therefore be at 12. So my rise is plus 8, my run was plus 4. Right? If I were to go further, for instance, and this time I did a run of and a rise of, okay, so I have another point that lies on the line. Let's say I had a run of, I'm going to say 6.
10.
What would my rise be?
12.
12.
It's
Okay, so where would that put the next coordinate? So if I start from 1, 4, this next coordinate would be at
11.
12 over 6.
7
16.
and 16, yeah? Because I'm going plus 6 to 7, and I know then I've got to go a rise of 12, so 4 plus 8 would be,
But say
sorry,
you're
plus
at
12 would
1,
be 16. Yeah?
And you add 6. Oh, I see now.
Yeah, okay.
I wasn't sure if I was supposed to add like 6 to 4 since
No, we've gone back to,
the original point.
because otherwise, if I started at this one, what would my rise and run be?
That would be 10. That would be 11. No, yeah, that would be 10. I was right.
Now, if I started at this point, and how far would I run?
8.
5.
2.
So 5 to 7 would be a run of 2 and a rise of 4. If I went between those 2 points. Yeah? Make sense? So I can use this to find any points on the line. Still, I can find lots of points on the line. I still don't have the equation of the line.
No.
So how can I use all this information to find? So the gradient's quite useful. I know what it goes up by. I can find all the points I like. Yeah, if I go across 1.5, how far do I go up? You going to answer me, or you got a question?
Answer.
Okay.
In a linear equation, isn't the gradient...
Hang on, that's not the question. Answer the question I've just asked. I'll come back to you then. If I were to go across 1.5, how far would I go up?
3.
On this line? 3. Okay.
Why would you go?
Because its rise over run has to equal 2.
Oh, it has to equal 2.
For this line, yes, because I've been told the gradient is 2. I'm not talking about any line here. I'm talking about this line that we've been asked about.
All of those have to equal 2.
Just this
Oh, I
line,
didn't
for
know that.
this line. I could give you a gradient of 3 and it would all change.
Yeah.
Yeah?
I know how to do. I just don't remember.
Okay. So I want the equation of the line. Okay.
So, I'm not sure this is 100% right, but for linear equations, isn't the gradient the coefficient of the x?
Okay. So the equation of a linear function, okay? So a linear equation has the form, as you've been seeing, y equals mx plus c.
Oh, that's what
Yeah?
we wrote.
I feel like we didn't use that.
Yes, we used it in the first
And-
lesson on the booklet.
The gradient is the value, the coefficient, as Jen said, of x. Take a guess,
It's the difference. It's the difference.
if you like.
I know how to solve a linear equation. I just don't know how to form it.
Right.
I know that it's like the difference.
So let's go through. Well, actually, if we know it's y equals 2x, then all right, we've got to figure out what we need to add to. Now, before I take any responses from anyone, I'd like you to have a chat amongst yourselves about what you think we're going to end up with. All right. See, so we know that it goes through 0.14. Come up with your method of doing it. How would you get to it? There's many methods. So have a chat.
Jen, we need to discuss what it is.
Right. So listen up. So yeah, we did just hear from Jen. We've actually got plenty of information here. So we know in several cases, I know my diagram's getting a little bit messy, but I've got some numbers here. I've got 1, 4 is a coordinate on that point, on that line. This point is 5, 12. This point is 7, 16. Now, do you remember what I said about a line? In fact, it's not actually a line. What is it? It's an infinite number of points. So every single point that makes up that line is linked by an equation, right? I should be able to use this equation to link 1 and 4, 5 and 12, 7 and 16. The same rule for anyone. I should be able to pick any of these points and find it using this equation, all right? So I know, for instance, that, well, every point goes up by 2. So this gradient being 2x, we haven't really explained why it is that. It's kind of one of those it is. I would like to explain it at some point. I just won't do it now. But I'll show you where that comes from. Why is it just 2x? All right? But we'll get there in a bit. So we do know that the gradient is 2. So we've got y equals 2x. Now from the points we have been told, x and y, well, 1 has to go into the function of x and give me the answer what?
4.
4. So I know currently that 1 goes into multiply by 2. That's this bit, 2x. So I have to multiply it by 2 and then I have to add something and get the answer 4. Right? So I wouldn't be writing it out in this way necessarily, but what I would be doing is this is what I'm thinking in my head. But what I can do is say, right, I'm going to substitute what I know in. So I've got the 4 has to equal 2 times 1 plus something. Yeah? So that's 2. Therefore, the plus something must be
2.
plus 2. So then I go back and say, well, it's got to be 2x plus 2 for it to work. Yes?
So, when would you know if, well, in this case it's C, how would you know if it was negative or positive?
Because when I get to this stage, I wouldn't be adding something, I would subtract something
Oh, okay.
instead. Yeah. Now I should be able to check as well. So for instance, another point is 5, 12. So I know that 5 has to go in and 12 comes out, and I should check that it does. So if I put 2 times 5, then add 2, what answer do I get?
12.
12. So I'm happy that if 5 goes in, 12 comes out. So there's my equation. It seems to work. All right? Make sense? So I'll give you another one. I'll give you 2. One is slightly easier than the other. All right?
Tell us which one's easier.
Well, you'll know. All right? So I'll give you a gradient of minus 3, right, through 0.31. Okay, or there's another one. So we'll have a gradient of 2 over 3 through point 30. So could you come up with the equation of one or both? If you feel that you just want to do the first one, fine. If you want to challenge, just go to the second one. If you feel, actually, I can do both, do both. If you do the second one, it comes easy, go back and do the first one anyway. Let's go through the first one. So, just out of interest first, what will this line look like if you put it on your calculator? Which direction will it go? Down, okay. So a gradient of -3 means it's going to be going down that way.
But couldn't that be up too?
No, because when we talk gradient, we always go running left to right.
Oh.
So then we say that if we talk rise over run, well, after I've done my run, my rise is actually not a rise, it's a fall. But a fall is a negative rise. Okay? So we always have rise over run, but we now know that if I go across 1, I actually come down 3, so -3. But anyway, what's the equation? So every straight line, and I've been told this is a linear function, it's a straight line, has a general form y equals mx plus c. Could use any letters. I've seen ax plus b as well used. All right? Doesn't matter. What we do know is that this m is the gradient. So I can start by saying it's y equals -3x plus c. Is that what you all did? Yeah? So now I've got my x value of 3 to put in, and I also know that my y value of 1 can go in there. And then I find my c. So now I've got y equals -3 times 3 plus c. So that is 1 is -9. So what do I have to add to get to 1? 10. So I have y equals -3x plus 10. Yeah? Fiona, if you got that right for me. Good. Well done. Right, so the second one, you're finding a bit more of a challenge?
C equals negative.
Don't forget, I don't just want HC equals. I'm asking you for an entire equation. So we have y equals
2 over 3
2 over 3x plus c. So x is 3,
over 1.
y is 0. Now, hopefully, well actually no, we can work with fractions. Svek?
So you do 3 times 2, which is 6.
Okay, let me write it out first. So 2/3 times 3 has to equal 0 plus something.
And then the next one is 0 equals 6 over 3,
Which is?
2.
Okay. Do you all see that? Instead of having to do 2 times 3 is 6, 6 divided by 3 is 2. If I do 2 divided by 3 times 3, I just have the 2, no?
Whoa. Wait.
2/3 is 2 divided by 3 times 3.
Oh, yeah.
2 divided by 3 times 3.
Yeah.
2. So I've got 0 has to be 2 plus c. Therefore, this is where we're saying I need to get from 2 to 0, so I need to subtract. So that'll be subtract 2. So now I've got y equals 2. What if I write it like this? Are you going to be happy? 2/3 of x is actually 2x all over 3 minus 2. It's the same thing.
So Does it matter if you write it the other way?
No, if you want to do 2/3 of x, I just wanted to do it to show you that they're equivalent. So if you get given that in a question that you're not unhappy to see it. Okay. What do we do now? So I've got 2 points. Now I know it's a line, so I've still got y equals mx plus c to find. What do you do?
Well, I did like a little thing. I don't know. Basically, I just went from 2 to minus.
Okay, so
Well, actually, I did the other way.
we're trying to work out gradient, yeah? So first step is work out the gradient. And the gradient is
5 over
rise over run. Now I'm going to give you a bit of notation here. That's right, Sophia, I'll tell you when it's time. The rise is the change in the y coordinates. So I'm going to give you this little symbol. It is a lowercase delta for anyone that does it in science. Have you seen delta something? Means change in physics, chemistry, yeah. This is just a lowercase delta. So it's like saying m and m. We have delta and delta. Now what people say is dy over dx, but it's not actually a d. It's a delta. Because when you differentiate, you are finding the gradient function, which we have to do. Right, so this is just another way of saying, now you might also have spotted, how do I work out the difference in something? Well, I would do one of them subtract the other one. Okay? So some of you will have been told this formula and try and memorise the formula. I don't actually ever bother, to be honest. So y2 minus y1 is just by doing, well, that's the second y coordinate I've been given. That's the first one. And this is the second x coordinate, and this is the first x coordinate.
Could you make that one your first coordinate?
Do it either way round you like. Doesn't matter. Alright? But actually, common sense is just this. Common sense would suggest that all I have to do is, I think like you did, my rise, I just go from one to the next. So that's minus 5.
Over
And my run is from x there to x there
minus 4.
is minus 4. So I've got minus 5 over
Minus 4.
minus 4,
Which
which is
is the same as 5 over
the same as 5 over 4, because we've got 2 negatives. Is that you zoning out again? No. So it was. Got you. Alright. Now that's my gradient. So now I've got this bit sorted. Is everyone there? Are you with me? So we've now got y equals 5 over 4x plus something. Now I've got 2 coordinates, one of which I can use and the other one I can ignore because it should work with both. So at this stage you can carry on and finish it off.
Go. You can make it straight.
Okie doke. Everyone, back with me? So we've got this question. We worked out the gradient doing rise over run. Something people were asking is, which one do I use? I can use either coordinate, as long as, like Sky said, I pick one or the other. Okay, so I'm going to use this one. Right? I could have used the other one, but I'm just no reason why. Maybe I just wanted to avoid the negative. Shh, please. Right. So I've got my gradient. I'm going to use that coordinate now to work out the c. So I've got 6 equals 5 over 4 times 2 plus something. Okay? So that would be 6 equals 10 over 4 plus something. Alright? Now there's 2 ways to do this. I could change the 6 into a fraction over 4, which is what I'm going to do. Or I could change the 10 over 4 into a Not a decimal. Well, I could, but I don't want to. I want to be better at fractions as a mixed number. But what I'm going to do is I'm going to say 6 is 24 over 4. The reason why I picked that is because I need something over 4. So I did 6 times 4 makes 24. Divided by 4 gives me the 6. So 24 over 4 is equal to 10 over 4 plus what?
C.
But C must be
A fraction.
14 over 4, no?
Y.
Because 10 over 4 plus 14 over 4 makes 24 over 4. So therefore, my equation is
3.5.
y equals
14.
5 over 4x plus 14 over 4. Now I could, however, change 14 over 4 into 7 over 2, which would be
3.5.
3.5 if I did it in decimal. Now, one final one. I'm going to skip over this one. I do have time, believe me, so don't pack things up. I will tell you when it's time to go. Right, I'm going to skip over this one. If you want to write this down and have a go at home, ready for next time, bit of practice, but I just want to mention this one. Right. What do you notice for this one about the rise over run? So the rise is from -1 to 7, which is plus 8. So I've got 8 on the top, but my run is 0 plus 0. So I don't have a run, which means the line is a
Straight, vertical.
well, I can only have parallel if it's
Circular.
2. No, it's a vertical line because there's a rise, there's no run.
Oh, so
Now, here's the problem. If the gradient is 8 over 0, what's one thing we already know we can't do?
Run.
No. Divide by
0.
0. So therefore my gradient is what we would call undefined because it's a vertical line. Alright? Therefore the equation of this line cannot quite be y equals gradient x plus c because there's no gradient. Therefore, and we're going to do more on this next time, the equation of this line has to do with something I know. And what I know is
Quadratic.
the x coordinate is always going to be 3. The y coordinate can be whatever it likes, but the x coordinate is going to be 3. So the equation of this line is x equals 3.
That's so weird.
That's the equation of that line. So these, Ali,
Sorry.
you should be paying attention, yeah? This should be important if it comes up in a test. Alright, so vertical line has equation x equals 3 because every x coordinate is 3. What do you think about horizontal line then?
Y will always equal.
Y equals
Negative.
something, yeah? Because it will have a gradient of 0. So we'll talk a lot more about that next time. But what can I ask you to do for me is can you review everything we've done today before next time and make sure that you're not coming at it completely, what did we talk about? So make sure you review it, please. Okay, off you go.